The root of artificial intelligence lies not in computers, but in a philosophical question that has perplexed humanity for millennia: does human thought follow a set of describable rules? From Aristotle's syllogisms onward, humanity has attempted to break down reasoning into standardized propositions. In the 17th century, Leibniz went further, dreaming of a universal symbolic language that would allow arguments to be resolved through computation. Until the 19th century, Boole used algebraic logic to compress thought into the binary zeros and ones. The greatness of this period lies not in the machines themselves, but in the crucial psychological construction it undertook. It pulled the mind out of the mire of mysticism, declaring to the world for the first time that human wisdom is essentially a set of manipulable formal systems. In the 1930s, the mathematical community began a frantic search for the endpoint of definition. In 1936, the genius Alan Turing proposed the world-changing Turing machine model, mathematically proving flawlessly that if a process is computable, it can be executed by some kind of abstract machine. This was not only a prelude to engineering but also a rigorous definition of the limits of mechanical thinking. In 1950, Turing abandoned the unsolvable dead end of whether machines have souls and instead proposed the famous Turing test. This step was crucial, successfully transforming intelligence from a profound philosophical speculation into an engineering goal that could be conquered. In the summer of 1956, at a seminar at Dartmouth College, the term artificial intelligence was officially coined. It was an era of extreme optimism, even arrogance. McCarthy, Minsky, and other future giants sat together, believing that given a group of top scientists a summer, they could solve all problems of intelligence, including vision and natural language. They firmly believed that every dimension of human intelligence could, in principle, be precisely simulated by machines. This God's-eye view instilled a logic-first gene into AI, but because it underestimated the complexity of the real world, it sowed the seeds for decades of disillusionment and struggle to come. Early AI was dominated by symbolicism. Researchers believed that intelligence equaled symbolic representation plus logical operations. They built massive reasoning systems that, given the rules, could prove mathematical theorems or play games like chess. Herbert Simon even asserted, within 20 years, machines will be able to do everything humans can do. However, this top-down logical system proved extremely ineffective when faced with the ambiguity of the real world, such as recognizing a cat in the grass. Symbolism proved that machines could possess advanced logic, but it couldn't teach them the most basic perception. The fact that humans don't think by enumerating rules ultimately shattered the illusions of symbolism. By the 1970s, the hype surrounding AI had burst. Machine translations were laughable, and robots struggled even to overcome obstacles. In 1973, the Lighthill Report harshly criticized the low productivity of AI research, and DARPA in the United States subsequently cut almost all of its funding. This was not merely a failure of computing power, but a bankruptcy of the cognitive paradigm. The first AI winter painfully revealed to people that the world cannot be fully defined by exhaustive rules. For the first time, AI was forced to admit that the intuition and common sense of humans were far more difficult to simulate than complex logical proofs. While symbolism dominated the world, another group pursued a connectionism approach. Instead of writing rules, they attempted to mimic the neural connections in the brain, learning by adjusting weights. However, a 1969 paper by Minsky demonstrated the limitations of early perceptrons, directly leading to a 30-year dark age for neural network research. During this period, neural networks were considered a dead end by mainstream academia, and researchers even dared not use the term in their paper titles. This was a poignant time of a minority preserving the flame underground, proving that scientific progress often arises from solitary perseverance and foreshadowing the eventual return of the bottom-up learning path. Even in the most desperate years, Hinton, Jan LeCun, and Benchio, the three men later hailed as godfathers, never gave up. They improved the backpropagation algorithm, invented convolutional neural networks, and, like monks, perfected the underlying mathematical tools in an era of scarce funding and difficult publication. They firmly believed that the structure of the nervous system was the ultimate answer to intelligence. Later, people realized that they weren't slow, but rather started too early. They prepared the algorithm engine alone in the dark, waiting only for the data and computing power, the two major fuels, to arrive in the coming decades. In the early 21st century, the internet explosion generated massive amounts of data, and AI quietly entered its eve of engineering. Research shifted from imitating the human brain to statistical prediction, with support vector machines and Bayesian models shining brightly in search and advertising systems. At this time, AI wasn't intelligent, but it was extremely useful. Silicon Valley companies realized that with enough data, algorithms could generate enormous commercial value. This was the realist period for AI. It abandoned its obsession with intelligence and embraced prediction, preparing the data fertilizer for the later explosion of deep learning. The real turning point didn't come from a sudden flash of inspiration in the algorithm, but from the quantification of cognition. Fei Fei Li realized that if the algorithm is the engine, then data is the fuel. She led the ImageNet project, leveraging global crowdsourcing to label millions of images. In 2012, the AlexNet competition emerged, crushing all traditional methods with an absolute advantage. This decisive victory proved to the world that it's better to feed machines massive amounts of experience than to teach them logic. Understanding no longer comes from rules, but from the accumulation of experience after scaling up, and deep learning officially took center stage. The explosion of deep learning is inseparable from a heavy industrial revolution in computing power. Jensen Huang astutely transformed GPUs, originally used for game rendering, into general-purpose computing engines, making parallel training of neural networks possible. AI's capabilities now obey a brutal yet simple formula: model size times data size times computing power equals intelligence level. Computing power enabled neural networks, which previously only existed on paper, to run on a large scale in reality. AI thus transcended purely theoretical science and officially transformed into a hardcore engineering race concerning capital, energy, and the scale of computing power. From 2013 to 2016, deep learning dominated various vertical fields. The accuracy of speech recognition, facial recognition, and machine translation surpassed the total of the previous 30 years in just a few years. Giants like Google declared AI first, completely restructuring their technology stacks. AI shed its mystique, no longer a cutting-edge technology in laboratories, but becoming infrastructure like electricity. It is no longer an independent functional module, but the default foundation for reshaping all productivity. In 2016, AlphaGo defeated Lee Sedol, marking a moment of collapse for humanity's psychological defenses. Its most striking aspect was that it didn't rely on human game records, but rather played against itself through reinforcement learning. Go was once considered the last bastion of human intuition, strategic thinking, and creativity. When this bastion crumbled, society realized for the first time that machines had entered the core of human cognition. This proved that machines could generate strategies that surpassed human experience. Intelligence was no longer a clumsy imitation of humans, but an independent exploration of the optimal solution in the universe. In 2017, the transformer architecture was born, and its self-attention mechanism reshaped the entire field of natural language processing. Previously fragmented tasks such as translation, summarization, and question answering began to converge towards a unified model structure. From BERT to GPT, language models evolved into universal intelligent interfaces. Language became a container for intelligence. People suddenly realized that as long as the statistical laws of language were mastered, AI could connect to and master all the knowledge representations of human civilization, a paradigm that paved the way for general artificial intelligence. AI has entered the deep waters of a battle of giants. Training a top-tier model requires hundreds of millions of dollars, signifying an extreme concentration of technological power. From Musk's focus on AI alignment to Microsoft's multi-billion-dollar investment in OpenAI, and Zuckerberg's commitment to the open-source path, AI is no longer just code. It has evolved into a core strategic asset for national competitiveness and global power. Computing power and models have become the new era's oil and nuclear energy, determining the dominance of future civilizations. ChatGPT's explosive growth marks AI's leap from perception to generation. Even more astonishing is its emergent capability. When the parameter scale exceeds a critical point, the model exhibits untrained reasoning, code, and multimodal understanding. AI has transformed from a useful tool into a collaborative agent with autonomous logic. It is reshaping the social contract of education, creation, and employment. For the first time, human civilization has encountered a non-carbon-based interlocutor. We are witnessing the birth of a civilization-level variable. At the final stage of AI evolution, a completely new role has emerged: the system-level AI architect. They are no longer just mathematicians in laboratories, but chief engineers who transform intelligence into productivity. They design complex model pipelines, balancing cost, safety, and efficiency. This marks AI entering a true engineering maturity period. Intelligence is no longer an expensive rarity, but is standardized and industrialized by these architects, delivered to every industry. This is an unprecedented new role in AI history. They are bringing the flame from the altar to humanity. The history of AI evolution is not a history of machines, but a history of humanity constantly revising how we think. This path is not over yet. We are on the eve of the most dangerous, yet most creative, singularity.